So far, everything we've done has been with right triangles. Okay, like our special right triangles, our trig ratios work for right triangles. Well, in life, not everything's a right triangle. I have to understand how to do things when it's not a right triangle. So we got two laws that we can use to solve for different side lengths and angle measures if it's not a right triangle. We have the law of sines and the law of cosines. Okay, so these are something that you're going to have to memorize. So the law of sines basically allows you to set up a proportion using sine. So for example, down here at the bottom, I have the sine of A over A equals the sine of B over B equals the sine of C over C. So basically, I can take the sine of the angle measure of A and set it up as a ratio over its side opposite, and I could set that equal to any of those others. So the sine of B over its side opposite B, or the same thing with C. And let's take a look at that. Once you see it in an example, it'll make sense here. Find P, round to the nearest tenth. Well, P, we're looking at this side length here. So my law of sine, well, first of all, to recognize when you need to use the law of sines, anytime you have an angle in the side opposite, that's when you want to use the law of sines. So here I got angle, side opposite, angle, side opposite. So I know I want to use law of sines here. Well, just grab one of the angles. I'm going to start with sine of 17. So sine of 17, I put that over its side opposite, which is P. And then I'm going to set that equal to, well, check your other measure, sine of 29. And put that over its side opposite, which is 8. And now you get a proportion to solve. And it's just our cross products. So I'm taking P times sine of 29. And setting that equal to 8 times the sine of 17. And we want to get P by itself. So we're taking it times sine of 29. The inverse is divided by the sine of 29. Whatever I do to one side, I do to the other. So it's just a little algebra to go with that. Okay, so P is going to equal whatever this guy is. Okay, and I could type that all into a calculator if I'd like. Just be careful. I would make sure that you put this in parentheses for your numerators and denominators, just to be safe when you put your division sign in there for the fraction bar. So I'm going to put my left parenthesis, 8 times sine of 17. Close my parenthesis for the sine of 17, and then put a right parenthesis for this red one right here for the numerator. Then divide, well, left parenthesis, sine of 29, right parenthesis for the sine, right parenthesis for the denominator. So just be careful when you type it in your calculator. And I should have gotten 4.8. 4.8. And there's no units on that, so I am just good to go. And it says what? Round to the nearest tenth, so I'm rounded. Looks nice. Very good. Find x, round to the nearest degree. Well, let's see if we can use our law of sines here. Looking at my angle measure, I got the side opposite, good. Looking at my angle measure, got the side opposite, good. So I'm using law of sines. If you can use the law of sines, do that. Much easier than the law of cosines. So looking for angles and side opposites. So pick one of your angles. You gotta go x. So sine of x degrees over, well, side opposite is 11. And I set that equal to sine of 50. And I put that over the side opposite, so over 10. Same thing, it's a proportion. So take the cross product. And 11 times the sine of 50 equals 10 times the sine of x. Well, I'm looking for an angle measure here. So you know eventually that you're going to have to use the inverse sine to find an angle measure. Well, let's go with our algebra. I want to get x by itself. So first of all, I got to move this 10 that's being multiplied by the sine. Well, to get rid of it, do the inverse, which is divide by 10. So I divide by 10 on both sides. So now I got 11 times the sine of 50 over 10 equals sine of x. And remember to, once I get sine of x, to solve for x, basically to switch their spots, I just take the inverse sine. So I got to take the inverse sine of 11 times the sine of 50 over 10, and that will equal my x. Make sure your calculator is in degrees. Okay, if you're not sure, I can come around and check for you, but that's what should be their setting. So inverse sine, I might put my parentheses around my numerator just so I'd be careful here. So I got left parenthesis 11 times the sine of 50 make sure you end your parenthesis, divided by 10. And end your parenthesis for the inverse sine. It looks like 57 degrees. It says nearest degree, so I don't need the tenth because it's about 57.4. So 57 degrees would be x. Okay, it's just following your algebra rules. Then using that trig ratio rule that we had. Anytime you need to find an angle measure, you always take the inverse at the end. Okay, set up the proportion. Hopefully, it should be pretty easy. Law of cosines a little bit more challenging. Okay, once we get to the examples, I'll try to make sense of it the best I can. So basically what happens here, if I don't know the angle on the side opposite now, and I can't set up my, my proportion with my sines, I use the law of cosines. Okay, so it almost kind of starts in a way like the Pythagorean theorem, right? A squared equals b squared plus c squared, except, you know, they just kind of get mixed around. And it all depends on what we're looking for. And then we always subtract 2 times the two sides that aren't on the outside of the equal sign. And then it's the cosine of the angle measure opposite the side that we put by itself. Okay, kind of confusing. I know this is a lot thrown at you. Once you see it in action, it'll hopefully make sense here. So get all 3 of these written down. Once you make sense of it, you won't really have to memorize it. That's kind of how I went about it. So let's take a look at an example. Just find x, round to the nearest 10. Well, first of all, I want to see if I can use the law of sines. So I got an angle, the side opposite. I don't have another angle, or I'm not looking for another angle, so I don't have another angle and side opposite, so I can't use the law of sines here. So now I'm thinking I got to use the law of cosines. Well, let's take a look. What are we trying to find? We're trying to find x, okay? And we know this angle measure of 45. So I know I'm going to have the cosine of 45 at the end. Okay, because it's the law of cosines. And I want to put this side by itself on the equal sign. Because if you notice, for example, if I'm looking at this angle measure, I always put the side opposite by itself squared on the equal sign. Okay, so let's go back. So I know I'm going to put x squared by itself. And I set that equal to, well, it's kind of like a squared equals b squared plus c. It's like the Pythagorean theorem in a way, right? Like 11 squared plus 25 squared. Okay, and then I take minus 2 times the 2 sides that I just used. So I just used these 2 sides. So I take 2 times 11 times 25. And then I finish it taking it times cosine of the angle opposite the side I put by itself, which we just said was 45. Okay, kind of sloppy there. So I got x squared equals 11 squared plus 25 squared minus 2 times 11 times 25 times the cosine of 45. So let's go through and simplify everything here. So x squared equals, well, 121 plus, this is 121, this is 625. I can put those together right away. So 121 plus 625 is 746 minus, let's simplify. Well, 2 times 25 is 50. 50 times 11 is 550. So I got 550 times the cosine of 45 degrees. Well, what can I do now? I want to solve for x. I got x by itself on the left side. So how do I get rid of that square? Well, do the inverse, square root. That'll cancel it, which means I have to square root this entire side. So x is going to equal, so I got to type this whole thing to my calculator. I got to go the square root of 746 minus 550 times the cosine of 45. Don't forget to end your parenthesis. And we end up with 18.896, blah, 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 blah. It says round to the nearest tenth, so x equals 18.9 for a distance. Okay, so the law of cosines. So it's just about figuring what angle you know and using the side opposite. So I knew the angle of 45, so the side opposite I put by itself squared right at the beginning, right? Then I put the other 2 squared, add them to each other, and then minus 2 times each of those sides that I just used. And then it's times the cosine of whatever angle you got. Let's try one more here. Find measure of angle L, round to the nearest degree. So anytime you're looking for an angle measure and you don't know any other angle measures, so basically if I know all 3 sides of the triangle and no angles, I have to use the law of cosines. Well, to figure out which one of these 3 sides we put by itself squared, on the left side of the equal sign, I gotta look, what angle am I looking for? I'm looking for angle L, so I look at the side opposite. So that's what I put by itself. So I got 24 squared equals, well, I was thinking kind of like the Pythagorean theorem, so I gotta take 5 squared plus 27 squared, the other 2. And then it's minus 2 times the 2 sides you just used. So 2 times 5 times 27. And then times the cosine of whatever angle. Well, the cosine of x, I don't know what this is. So I'm just going to call this x degrees right now for that angle L. And now let's just go through and simplify everything we can simplify. So 24 squared gives me 576. I got 25 right here, and 27 squared gives me 729. So I'm going to simplify that right away, which ends up with 754. Okay, minus 2 times 5, which is 10 times 27 is 270, times the cosine of x. Oh yeah, so let's start thinking here. I got to get x by itself. Well, eventually I'm going to have to do the inverse cosine, aren't I? Because I got to solve for an angle measure. Well, I'm going to have to get this cosine of x all by itself. So right now it's being multiplied by a negative 270, and it also is being added by a 754. So this goes back to your algebra rules. It'd almost be like if I had something like this. If I had like 3 minus 2x, what do I do first? Well, I subtract 3 from both sides, right? Wherever that equal sign is. So that's just what I'm thinking. I got to subtract 754 from both sides. Follow your algebra rules. And so now we end up, well, 576 minus 754 gives me negative 178. That's gone. I still have negative 270 times the cosine of x. Well, to get the cosine of x by itself, we got to divide by negative 270. Divide by negative 270. So that's gone. So I got the cosine of x equals negative 178. I'm going to leave this just like that. I don't want to round anything yet. So don't round any decimals, because otherwise you won't be very exact. So remember now, to solve for x, basically to switch their spots here, I have to take the inverse cosine. So let's come up here. So I take the inverse cosine of whatever ratio I got. So negative 178 over negative 270. I could just put positives, right? Because negative divided by negative is a positive. Is going to equal that x degrees. So make sure you get to your inverse cosine and not cosine. So I have negative 178 divided by negative 270. So I'm taking the inverse cosine of that. And x is going to equal 48.75. It says to the nearest degree, so about 49 degrees. So it takes a little bit of algebra. Okay, so just you have to think through. Go back and maybe rewatch how I initially set that up, so you get used to how you can set up that law of cosines, so you can get used to it. Then you don't have to memorize the formulas, right? Just understand how it works, and then it's much better for you. All right, that's all I got.